Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see parallel connection of capacitors. For that, we will consider a circuit which has one current source I and a number of capacitors connected in parallel. As we know that the voltage across all the capacitors in parallel connection will be same, and current flowing through each capacitor will vary according to its capacitance. For definition of parallel connection, please watch my resistors in parallel connection video. I will provide the link in the description. If not watched earlier, please watch it out. To find out the amount of current delivered by the current source, we need to find out the equivalent capacitance of this circuit. To find out the equivalent capacitance of this circuit, we need to apply the Kirchhoff's current law. Kirchhoff's current law is stating that the algebraic sum of incoming currents and outgoing currents is equal to 0. If you are considering that this is the node, we will apply Kirchhoff's first law to this node. The incoming current is I, that is the direction of I is will be like this, that is towards the node, and the currents I1, I2, I3 up to IN is outgoing currents, so the arrow is downwards. If we are applying the Kirchhoff's current law here, as per Kirchhoff's current law, the incoming current can be write as positive and outgoing currents can be write as negative. So incoming current is I have write in positive, and rest all the currents are outgoing currents. We can write it as negative. So I1 minus I2 minus I3 and up to minus IN, which is equal to 0. If we are transferring all the I terms to the right hand side of this equation will become I is equal to I1 plus I2 plus I3 plus up to plus IN. Now we need to apply the values of capacitance and the voltage terms in place of I. So for that, we need to know the basics of capacitance. Capacitance is a two-terminal device. The capacitor is having two plates which are separated by a dielectric medium or the insulator, and if the capacitor is connected with the voltage source like this plate can be called as positive plate of the capacitor, and this plate can be called as negative plate of the capacitor. The basic property of this capacitor is to store the electrical charge. The amount of charge stored in a capacitor is equal to the multiplication of capacitance of that capacitor and the voltage across the capacitor. So we can write Q is the amount of charge stored in the capacitor is equal to capacitance of the capacitor and the voltage across the capacitor. Okay. Now we know one more definition that for the current can be defined as the amount of charge transferred per unit time. So we can write I is equal to dq by dt. If we can mark this equation as first and this is the second equation, we need to apply the derivative part on both sides of this equation 1. So if you are applying the derivative part, so equation will become dq by dt is equal to d by dt of cv. And as we know that capacitance is constant, so on solving this equation with the differentiation formula, we will get c into dv by dt, and in place of dq by dt we can apply I. Okay, now this is the value of I which we need to apply in this part, in this equation. Okay, now we will start to apply. Now I is the current delivered by the source. For that I can write C equivalent. I don't know the value of capacitance, so I'll write C equivalent into dV by dt. As voltage is constant, I will write dV by dt, which is equal to I1. I1 is the amount of current flowing through C1. So C will be C1 and voltage is constant, so we can write dV by dt, and same manner for all other current terms. C2 I2 will be the current which is flowing through C2, so we will write C2 dV by dt, plus I3 is the amount of current flowing through the C3, so we will write C3 into dV by dt, and so on. The nth capacitor will be Cn and voltage will be dV by dt. Okay, now we will further simplify this equation. So we can write this term as same as it is, Ceq, that is equivalent capacitance into dV by dt, and the common term in the right hand side of this equation is dV by dt, so we will take it out, dV by dt, and remaining terms will be C1 plus C2 plus C3 plus up to Cn. We can cancel out the equivalent terms in both sides of this equation, so remaining will be C equivalent, which is equal to C1 plus C2 plus C3 and up to Cn. Now we can also write this equation as summation of I is equal to 1 to n Ci. This means the equivalent capacitance of a parallel combination circuit will be the summation of individual capacitance value, and the equivalent capacitance will be higher than the highest capacitance which is connected in the circuit. So this is the if you are looking this equation, this is same as the resistors in series connection. If you have any doubts, please comment on the comment box. I'll reply. If you have not subscribed my channel, kindly subscribe it. Thank you.